180 kg Aditya L1 spacecraft into Earth-bound orbit, from which it will be placed into a halo orbit around the L1 point in 4 months. The satellite is intended to study the Sun and how it impacts the halosphere. The Sun, which is the center of our solar system and has always fascinated humans, is a ball of hot gases formed by the nuclear fusion process. The visible outer surface of the Sun is known as the photosphere, followed by the chromosphere and then the corona. After initially dropping through the chromosphere, the Sun's temperature abruptly rises in the corona, reaching extremely high values of 1 to 3 million Kelvin. The Aditya L1 mission has 7 scientific payloads to conduct a comprehensive study of the Sun. The Visible Emission Line Coronagraph, VELC, investigates the solar corona and the dynamics of coronal mass ejections. The Solar Ultraviolet Imaging Telescope, SOOT payload, scans the solar disk in near ultraviolet light and detects fluctuations in solar irradiance. The Aditya Solar Wind Particle Experiment, ASPECS, and Plasma Analyzer Package for Aditya PAPA payloads investigate the solar wind and energetic ions, as well as their energy distributions. The Solar Low Energy X-ray Spectrometer, SOLEXIS, and the High Energy L1 Orbiting X-ray Spectrometer, HELIOS, analyze X-ray flares from the Sun over a wide energy range. The magnetometer payload is designed to measure the interplanetary magnetic field at the L1 point. Aditya L1 is equipped to take in situ measurements of charged particles and fields at L1 and is dedicated to studying the Sun across several energy bands. The Lagrange point L1 is located around 1.5 million kilometers from the Earth between the Sun and the Earth. These observations are best made from a vantage point that provides a continuous view of the Sun. All payloads are designed in close coordination with ISRO centers and national laboratories like as IIA, IUCAA and PRL. With this mission, ISRO will once again demonstrate its position in space exploration.
Sun known as core, the temperature can reach as high as 15 million degrees Celsius. Power source for the Sun is nuclear fusion of hydrogen atoms that takes place in the core. The visible surface of Sun is relatively cool and has a temperature of about 5,500 degrees Celsius. The Aditya L1 spacecraft is planned to be placed in a halo orbit around the Lagrangian point 1 or L1 of the Sun-Earth system, which is about 1.5 million kilometers from Earth, roughly 1% of the distance to Sun. A halo orbit is a periodic three-dimensional orbit near the Lagrangian point in the three-body problem of orbital mechanism. The object in this orbit stays in place by the gravity of Earth and Sun. It requires little energy for station keeping. Several probes have been placed in space to observe the Sun by various space agencies. Lagrange's point L1 is a great location for solar explorers such as Aditya L1, as it allows for an unobstructed view of the Sun that is never eclipsed by Earth. At L1, Aditya L1 will join spacecraft such as ESA-NASA's Solar Heliospheric Observatory or SOHO, which has been at L1 since 1996.
लैग्रांज पॉइंट एक ऐसी जगह है अंतरिक्ष में जहां अगर कोई चीज़ पहुंचती है तो वह वहीं बनी रहती है, क्योंकि लैग्रांज पॉइंट पर दो बड़े द्रव्यमानों का गुरुत्वाकर्षण खिंचाव बराबर हो जाता है और इसमें एक अभिकेंद्रीय बल है कि जो कि पिंड को दोनों द्रव्यमान के साथ बनाए रखता है। ऐसे 5 लैग्रांजियन पॉइंट्स होते हैं पृथ्वी और सूर्य के बीच। इन पॉइंट्स में अंतरिक्ष यान को भेजकर कम से कम ईंधन की खपत पर या उस स्थान पर अंतरिक्ष प्रयोगों को अध्ययन के लिए बनाए रखा जा सकता है। आदित्य L1 उपग्रह को भी ऐसे ही लैग्रांज पॉइंट 1 पर स्थापित किया जा रहा है। अंतरिक्ष यान को यहां तक पहुंचने में 125 दिन का समय लगेगा। इस लैग्रांजियन पॉइंट्स के कुछ फायदे होते हैं, जैसे हम यहां आदित्य L1 के बारे में बात कर रहे हैं तो यह अंतरिक्ष यान लैग्रांजियन पॉइंट 1 के पास जाएगा और यहां ऐसा पॉइंट है जहां से सूर्य को बिना किसी ग्रहण या रुकावट के निरंतर देखा जा सकेगा और अध्ययन किया जा सकेगा। दूसरा फायदा यह कि विभिन्न मापन या विश्लेषणों के लिए किसी भी तरह की रुकावट या कमी नहीं आएगी। वायु न होने की वजह से इससे दूर तक स्पष्ट देखा जा सकेगा। लैग्रेंज पॉइंट पर इस वेधशाला को रखने का मुख्य कारण यह भी है कि यहाँ उपग्रह लगभग स्थिर रहेगा और उपग्रह के अभिवृत्ति नियंत्रण के लिए अधिक ईंधन की आवश्यकता नहीं होगी। वर्तमान में PS4 चरण का कोस्टिंग फेज जारी है। अब यान की ऊंचाई 280 किलोमीटर तथा सापेक्ष गति 7.18 किलोमीटर प्रति सेकंड है। अब यह उचित अभिवृत्ति प्राप्त कर पुनः प्रज्वलित किया जाएगा।
Vehicle performance normal.
The Aditya L1 spacecraft carries 7 payloads to observe the protosphere, chromosphere, and corona, which is the outermost layer of the sun. These payloads use electromagnetic, particle, and magnetic field detectors. First among the 4 remote sensing payloads is Visible Emission Line Chronograph, VELC, which is a prime payload designed as a reflective coronagraph with a multislit spectrograph. This payload is developed jointly by Indian Institute of Astrophysics, Laboratory of Electro-Optical Systems, UR Rao Satellite Center, ISRO Inertial Systems Unit, and Space Applications Center. The second payload is Solar Low Energy X-ray Spectrometer, or SOLEX, designed to measure the solar soft X-ray flux to study solar flares. This payload is developed by UR Rao Satellite Center. Third payload is the Solar Ultraviolet Imaging Telescope, SUIT, which is a UV telescope to image the solar disk in the near ultraviolet wavelength range. The payload is developed by Inter-University Center for Astronomy and Astrophysics, Pune, LEOS, URSE, and IISU. The fourth payload is High Energy L1 Orbiting X-ray Spectrometer, or HELIOS, developed by URSE. Is a hard X-ray spectrometer designed to study solar flares in high energy X-rays. The fifth payload is the one which is meant for in situ observations. This is Aditya Solar Wind Particle Experiment, or otherwise called as ASPEX, which comprises of spectrometers to measure low energy particles and high energy ions. This payload is developed by Physical Research Laboratory. The sixth payload is Plasma Analyzer Package for Aditya, in short, PAPA. It is designed to understand the solar winds and its composition and perform mass analysis of solar winds. This payload is developed by Vikram Sarabhai Space Center. The seventh payload is a magnetometer, or MAG, developed by LEOS, which will measure the low intensity interplanetary magnetic field in space using a pair of magnetic sensors.
जी हाँ, आदित्य L1 उपग्रह में निदभार के बारे में जानते हुए इसमें सुदूर संवेदन निदभार हैं और यथास्थिति